Okay, Algebra 2. I'm going to try to go through this quickly because the video has been cutting out on me. YouTube is somehow not working the greatest today. So 5-6 is about a new group of numbers in the universe which you've not really talked about, called the complex numbers. Well, you've talked about half of them, but you haven't talked about the other half. The other half, the ones you don't know about, the first part, I guess, is the half that you do know about. They're called the real numbers. That's every number you've ever dealt with in your life. Well, there's another half to the complex numbers called the imaginary numbers. Now, I know that's an unfortunate name because all of you are going to say, well, they're imaginary. How come we have to deal with them? Because I can't see them. Well, they only mean the imaginary numbers, or the only reason they got that name is because we usually think of real and tangible and something you could feel. We call this group of numbers the real numbers. So the other group, something that's completely separate from that, would have a name like the imaginary numbers. Okay? Now, it's based upon a definition, the square root of -1. Well, we know the square root of -1. That's not a decimal. There's no number in the real numbers which you can multiply times itself and get -1. So we use the letter I to represent that, and this is called an imaginary number. If you square both sides, you get I squared over here, and the square root and the square cancel out and give me -1, which is a kind of a really weird thing. You could take two numbers which are not real, they're both imaginary, you can multiply them together and you can end up with a real number, -1. And I hope as we go along that you will see that fact and you'll use it. I talked to you yesterday about something like this, the square root of 8, simplifying that radical, and how you would take the largest perfect square you can find in 8, which is 4, and you would break it apart into 4 and 2, right? Radical 4, radical 2. Then you would simplify the square root of 4 and leave the radical alone. We talked about the perfect squares and the leftovers. Well, a very similar thing happens when you have the square root of -8, except you've got one little extra detail. You still have the perfect square. You still have the leftover, but there's a square root of -1 also included, because 4 times -1 times 2 is -8. And this is where you'll find the imaginary portion. You've got a 2. We know the square root of 4. This is the part that gets substituted with the letter I, and then we have radical 2 over on the right. So we quote it as 2i radical 2. Not that much different, but yet it is indicating that one's an imaginary result and one is a real number. Irrational as it may be, it is a real number. So, square root -32. Now we can think of this as 16 with 2 left over and a -1. So that's a 4, that's an I, and that's a radical 2. So 4i radical 2. Now if you want, you can always bring the -1 in with the perfect square. So we could have split this apart into those two pieces, simplified this one to be 4i, and left the radical 2 alone. As I was saying, if you know that the square root of a negative perfect square is just 5i, like square root of -25 is just 5i, then you could simply write that. You don't really need to split it apart into two things. Every complex number is based on two things, a real number and an imaginary number. And so you'll hear a lot of times a plus bi. You'll see it written in several questions. Something like, rewrite the complex number in a plus bi form. And that's what example 2 talks about. Write the complex number in a plus bi form. Well, when you look at an example like this, it sure looks like there's a real number. That would be this one over here. And then there's an imaginary one sitting right here. So the square root of -9, that's the 3i, and of course the 6, I can't do anything with that. Now if you want to write it in a plus bi form, that's the real number comes first and the imaginary number comes second, you would have to reverse this, right? Now, can you graph these particular points? Yes, you can. Have you ever seen a real number line? I'm sure you have. We plotted points on it at the beginning of the year. We even drawn open circles and closed circles and shaded arrows left and right. Well, what you never knew, because we never talked to you about, was the fact that there was a another axis that ran through 0, a vertical axis. This vertical axis contained all the imaginary numbers. So they call this one the real axis. They call this one the imaginary axis. We just never talked to you about it. So this is, overall, this one's called the complex number plane. Now, how do you graph 6 plus 3i? It's really not all that complicated, right? 6 reminds me of the x value. 3i reminds me of the y value. So this is the location in the universe called 6 plus 3i. Now this dashed line, I'll tell you what that means in a second here. But this is the coordinate. If I asked you to graph the point, I just want that particular point. Now, if I ask you for the absolute value of a number, what would you say? You would probably say, well, what's the absolute value of 2? The absolute value of 2 is 2. What's the absolute value of negative 2? Also 2. You would say it's the distance away from 0. But when you take a point that's here and you ask for its absolute value, you are really asking for its distance away from 0 plus 0i. So, how do you find the distance from that point to here? Well, doesn't this remind you of a right triangle? With a distance of 6 on this side and a distance of 3 on that side? And don't we know that to find that distance, it's the Pythagorean Theorem? And you'll notice that when I do this, okay, the absolute value of this being the square root of 6 squared plus 3 squared, there are no i's involved, folks. I don't take 3i and square it, I just take the 3. It's the imaginary portion of the imaginary number. I do not take the I. So, 36 plus 9 equals the square root of 45. Can we simplify that radical? Sure we can. There's a perfect square trapped inside of it. So we can say this is 3 radical 5. Perfect squares and leftovers. But I got to go back to that. Do not throw an I in here. These are easy questions. Please don't lose points on the easy questions. Last question I have for you is, what's an additive inverse? So what's the additive inverse of negative 6? It's a number in the universe that you can add to negative 6 that will end up giving me 0. The answer, positive 6. So what's the additive inverse of 2 minus 5i? Something I can add to it and end up with 0 plus 0i. That'll be negative 2 plus 5i. Yes, it is that easy, folks. Additive inverse means the opposite. Here, I'll put complete opposite. So negative 3 minus 2i has a complete opposite of positive 3 plus 2i. Probably the easiest points you can pick up on a quiz or test. Please make sure you get those points. Those are easy ones. All right. Watch. We'll see you in class. Well, the sub will tomorrow. But I'll talk to you soon.